Okay, so now we're going to talk about how to calculate the pH of salts. Salts are actually a broad category of compounds. They're more than just NaCl. NaCl is table salt. It's one most people are familiar with. But salts are actually a broad category. They are the product of an acid-base reaction. So when you have an acid-base reaction, so for example, NaOH, HCl, we've done this before, double replacement reaction, the H and the OH end up together as water and you get NaCl. This product, other than the water, is a salt. There are different examples of it, but that is the common one most people see. Because salts are the product of acids and bases, they can affect the pH of the solution. If it is a neutral salt, like NaCl, the pH is 7 because the cation and anion of the strong base and strong acid are too weak to react with water. So the only thing that dissociates is the water, pH 7. Basic salts have a pH greater than 7 because what you have is you have something at the beginning, the cation of a strong base, it's too weak to react with water. But what you have is you have an anion of a weak acid. This would be a conjugate base, and it forces water to act as an acid. And you have acidic salts. They have a pH less than 7 because the anion of the strong acid is too weak to react with water. But the cation of the weak base, which is a conjugate acid, can force water to act as a base. The hardest thing about this is not the math. You guys can do the math. The hardest thing about this is identifying what acid and base created it. What kind of a salt is it? What is the reaction going to be? That's the hardest part. In a basic salt, you have a conjugate base of a weak acid, and it is stronger than water, and it will determine the pH. So weak acid, strong base, basic salt. All right, it is BS. Okay. For example, NaOH is a strong base. HF is a weak acid. Therefore, I get a salt here. This is a basic salt. When the NaF forms in water, the Na plus is so much weaker than water because it's something strong. So we always cross out the strong things. The F minus, on the other hand, is a stronger base than water and can force the water to act as an acid by donating a proton to this conjugate base and producing hydroxide, which is what makes it a base. Okay, you should expect to get a pH greater than 7. The thing is, though, if this is my weak acid, it will have a Ka. This is the conjugate base of a weak acid, and I need to know what its equilibrium constant is. So to determine the pH of any salt, you need the Ka and the Kb of the original weak acid or base. Whatever is the weak one that has a K, you need to know the other K for it. So for any conjugate acid-base pair in our last example, it was HF and F minus. This was the weak acid, and this was the conjugate base. The Ka times the Kb is 1e negative 14. So if the Ka of HF, which is my acid form, what is the Kb of this? I have 7.2e negative 4 times Kb is 1e negative 14. All you have to do is divide. You get 1.39e negative 11. And we're going to use that in the next problem. But that's how you find the missing K value. And you'll have to do that for every salt. So the dissociation reaction of NaF and water, and then we're going to calculate the pH of a 1 molarity solution. So first of all, you want to always eliminate anything that is a strong ion. That means Na, Li, K, and Rb. So I'm going to get rid of that. I'm getting rid of the Na, and my reaction, which is the hardest part, is F minus added to water. If this is my acid, this is the conjugate base of a weak acid, which means it's going to act like a base. That's the acid form. This is the base form. Bases accept a proton. You get HF and hydroxide. That's a dissociation reaction. That is the hardest thing. Once you figure that out, it's relatively redundant. I'm not sure if that's even the right word. It's relatively easy to set up the ice table because you guys have done them so many times. This starts as 1 molarity, 0, 0 plus x, and minus x, 1 minus x. So when you set it up, I don't know why my computer is doing this. I think I need a new tip for my stylus. Anyhow, I have x squared over 1 minus x, but that is the equilibrium constant, but that is for this thing. That is a base, which means I need the Kb. Even though the Ka is given up here, that's for the acid. This is the base. I need 1e negative 14 over 7.2 e negative 4. You're going to assume x equals 0 with respect to 1. Do your math and solve for x. 3.73 e negative 6. Recognize what that represents is x for hydroxide. So if you do negative log of that number, you'll get a pH of 5.43, which means your pH is not 8.57. So not nearly as high of a pH as a strong base or even a weak base. It tends to be closer to 7, but it is definitely above 7, which makes it a base. Okay, acidic salts, they have a cation of a weak base and an anion of a strong acid, and they are an acidic salt. The anion of the strong acid is much weaker, so it will be the spectator, and the cation will form with water, react with water to form H3O+, which makes it an acid. Weak base, strong acid, acidic salt. That's an S. And you should expect to get a pH less than 7, and don't forget you're going to need the other K. So these tend to be a little bit harder. So if I look at this and I see that that is Kb, I recognize this inside here as being the product of NH3 plus HCl. HCl is my strong acid. So my spectator ion is Cl. So I have NH4 plus water. And then because this is the base of this guy, that means that is the conjugate acid of a weak base. So NH4 is going to act like an acid, and it's going to donate a proton. You'll get H3O plus and NH3. Big X here. This is 0.400 plus X. And again, you have your same process of setting up the ice tables. I don't know why it is doing that. I think I really do need a new stylus. You have x squared over 0.4 minus x equals, but again, this is acting like an acid. I need the Ka, which is 1e negative 14 over the Kb that they give you. Do your math, solve for x, which represents the H3O+. You can assume x is 0 with respect to 0.4. Do your math. Stop doing this. And you get x is 1.5 e negative 5, and the pH, again, is less than 7, but it's not nearly as extreme as even a weak acid. It's 4.83. Tends to be a little closer to that 7 mark. Okay, so what happens if you have a weak acid and a weak base together? It's not on the AP exam. You might have to see that in college, but for right now, it's not on there. Okay, here's how you identify things. Acids start with an H. These are your 5 strong ones. H2SO4 also counts, but you'll never see any math with that. Weak acids start with an H and have a Ka. Strong bases are things like Li, Na, K, or Rb with OH. Those guys in particular. The metal ions. Okay, those are the only strong bases. There's only 4. We have 5 strong acids and 4 strong bases. Weak bases have a Kb, and a lot of times they have a big organic chain with NH and then some number next to the N or the H, and it's got this organic chain off to the left. Salts, and this is the hardest thing, if they start with Li, Na, K, or Rb, or they end with Cl, Br, I, ClO4, NO3 minus, or they do both, they are a salt. So if it starts with the Li, Na, K, Rb and ends in OH, it's a base. If it ends with these guys and starts with an H, it's an acid. Other than that, they're salts. If they end and start with one of these and end with one of those, they are a neutral salt and the pH is 7. Okay. Basic salts have the following formulas. So they have that metal again, Li, Na, K, and Rb. And then they've got some other anion that comes from a weak acid. Okay, so you're only going to use the anion in water and water. You're going to cross off that metal, and it's going to produce H plus attached to the anion because the anion acts like a base, and it's going to produce hydroxide. That means you need, God, I really need a new stylus. You need the Kb. Kb. Acidic salts start with that long organic chain, perhaps, with some anions, Cl minus, Br minus, I minus, NO3 minus, or ClO3 minus. You're going to cross off these guys. The anion gets crossed off. It's going to act like an acid in water, and it's going to produce H3O plus and RNHX minus 1. God, this is really annoying. So we're going to try some. Okay, so first of all, you have to identify what kind of salt it is. And the first thing you want to do is you want to eliminate any strong ions. I'm not going to calculate the pH for these. I'm just going to set them up. So if I look at this, NaCl starts with a metal, ends with one of my anions of a strong acid. Both of them cancel out because this is a neutral salt. My reaction is 2H2O, goes to H3O plus and OH minus. These start at 0. They both gain X. I have X squared is 1e negative 14, which is the equilibrium constant for water. X is 1e negative 7. That refers back to H3O plus. That's why the pH of water is 7. pH of neutral salts are 7 because the only thing you have floating around that's doing any dissociation and producing H3O plus are your water molecules. Okay, this one you're going to get rid of the K. Starts with a metal, tells me this is a basic salt. I could also have figured it out from here. If this is the acid form right here, that's the base. My reaction is Cn minus plus H2O goes to HCN plus OH minus. And with that one, you're going to need the Kb. That's the Ka for the acid form. This is a base. You need the Kb. This one I'm going to get rid of Cl. That comes from my strong acid. If this is the base form, NH2, NH3 is the acid form. Your reaction is C2H5NH3 plus H2O goes to H3O plus and C2H5NH2. And again, you need the other K. That's the Kb of this guy. This one is acting like an acid. You need the Ka. Okay. Last one is ranking the 1 molarity substance from lowest to highest pH. This would be most acidic, and this would be most basic. So we're going to identify the strongs first. HCl is a strong acid, so it belongs over here. KOH is a strong base. It belongs over here. Weak acids and weak bases get closer to them, so HNO2 is a weak acid. CH3NH2 is a weak base. Okay, my neutral salt comes from a strong acid, strong base reaction, KCl, gone. And then this one starts with a metal, tells me it's a basic salt, KNO2. And this one ends with a strong acid, so it's an acidic salt, CH3NH3Cl. Okay, they will never give you where you have 2 weeks of acids or 2 weak bases or 2 acidic salts. It's going to be obvious how it works.